Imagine catching data issues before they snowball into bigger problems. That's what Datafold's new monitors do. With automatic monitoring for cross-database data diffs, schema changes, key metrics, and custom data tests, you can catch discrepancies and anomalies in real time right at the source. Whether it's maintaining data integrity or preventing costly mistakes, Datafold monitors give you the visibility and control you need to keep your entire data stack running smoothly. Want to stop issues before they hit production? Learn more at dataengineeringpodcast.com/datafold today. Your host is Tobias Macy, and today I'm interviewing Ken Pickering about streaming data into a Trino and Iceberg Lakehouse. So, Ken, can you start by introducing yourself?
Hi, yeah, thanks for having me on. I am the VP of Engineering at Going, which is a company that provides travel deals for consumers.
And do you remember how you first got started working in data?
It's a long time ago. So I came up from like product engineering, but I found over time that more and more of the requirements I was working on involved data in some capacity. And so I think it started with e-commerce and InsurTech, really, which were based on pretty large volumes of data at the time. So recommendation algorithms for e-commerce, and then like I worked for a property insurance company where we'd like be able to price like roughly what would be in a person's home, based on region, size of house, like that sort of thing. And so that's where I really got interested in the topic of it. And more of my career has like pushed further into interpreting and then productizing data in some capacity.
Your current role is in Going, where you're leading their data platform. And I'm wondering if you could just start by giving a bit of an overview about the types of data that Going relies on and the role that it plays in the business.
So yeah, so Going needs to find travel deals. It's a subscription service. So you sign up and we try to find travel deals for you. And more that becomes a data intensive problem. And there are sort of two aspects of that. One is, well, how do you find flight prices? It's a very large problem domain, and so sort of computer science terms, it could be classified in some capacities as like NP complete, because you can get to a lot of places via a lot of routes. And so like trying to find deals for customers is sort of part of that problem space. And prohibitively the volumes of data, the data volumes you're dealing with are prohibitively large in some capacity, and so you have to figure out how you want to traverse that. And so ingesting large volumes of flight information and flight data is one aspect of it, and building models around, well, is this a good price or a bad price? If you have a specific itinerary you're trying to follow that's different than finding a globally available like deal. And so like we try to focus on sort of both those problems and just advise people when a good time to travel would be. And then there are concepts like, personalization, like whatever a person's interest, what kind of deals apply to them. Because when you deal with like a mobile form factor, making sure that you're giving like timely, topical, and sorted information is interesting. And so, and I'd say expected from a modern consumer as to how they use their apps today. So and so I'd say we collect, yeah, basic travel information, what do flights cost, segments and routes and all that sort of fun stuff. And then the other side is like event stream information. What are people doing on the device, and how can we provide a better service to them based on that input?
You mentioned a little bit about the size of data that you're dealing with,
Yeah.
but in terms of the overall volume, variety, velocity, what are some of the characteristics that you need to accommodate to be able to fulfill the data oriented objectives of the Going system?
So one way we've solved the problem is both through passive and active search. And passive search is where a lot of data comes in. Active search is when we search for flight prices. It's a transactional where we send out a query, we get a response, a request coming back in, and it's a pretty manageable data. The passive data is sort of like where we aggregate with a very large, it's called a global distribution system, GDS. It's how a lot of online travel agencies search for airfare. And what we do is we get access to their global traffic. And so each of them can give you about at least a gigabyte a second of travel data. And if you do the math out, it's about 50 petabytes a year of data you're kind of sifting through for each provider. And so like that is sort of the relative volume of it. And it's kind of messy data in that it's like really like nested JSON. And so there is a fair amount of pre-processing you have to do to be able to derive action from it. But our goal is to try to kind of sift through that haystack and find a needle of like good deal flight pricing for our customers. And so, I think the reason that we solve the problem with streaming in many capacities is because time matters in these types of situations, because flight prices fluctuate. The sooner we identify a deal and the sooner we notify our consumers of a deal, the more likely that deal is being able to exist when they go to transact on business. Because, flight prices can change a few times a day. And because you don't know how long that deal has been in place in some capacity, you get a notification of it from a passive search that somebody else did, but you don't really know how long that price has been active because there's not really a great system for publication and broadcasting that. So that's why we went with a kind of a real-time streaming nature with the architecture. Because of the cost considerations, that's also why we tried to land it in our warehouse in Iceberg in real time. Because if you're already processing the data, because it's like a large amount of data and it's kind of a messy format, and you already have extracted what you're looking for out of it, it makes sense to transform and land as well.
And before we get too much more into the technical architecture, I'm also interested in the composition of your engineering and data teams that manage and support and consume these data flows, where typically, if you're dealing with analytical data, then a lot of that responsibility lives with a separate team from your software and application engineers. But given that the data is a core capability of the actual product, I'm curious how that influences the ways that you think about the composition of that engineering talent.
Going engineering is small and fierce. It's about 25 people right now, so we all work together. I mean, we're still a startup in that capacity where there aren't really huge organizations and big departmental silos. But yeah, it does require close coordination between how we are operating as a team. So we do have people that specialize in data engineering. We have two data engineers and a manager that oversees the two data engineers and our one data scientist, Nick, who does an amazing job for being our solo data scientist. But we rely on a lot of vendor tooling. I mean, in this ecosystem, like when you don't have very many engineers, we've kind of strung together a series of SaaS tools that let us streamline engineering operations. So we're mostly focused on, I would say, how we efficiently transform data on the data engineering side, and then how we efficiently model that data on the data science side, and worry less about like the operational side of data engineering, which we push off to vendors. But and then in terms of how people interact, like a lot of it comes from product management. Like we will develop models, but at the end of the day, we have to work closely with product and the product teams to be like, okay, we have a statistical valuation of this price, but how do we present that to a consumer in a way that makes sense? How do we measure like notification threshold, and when we should push something to users versus when we should observe and see if a price gets better, and then talk to our customers about it. How do we display a lot of the rich information we collect and generate to customers so they can feel like they're making an informed and educated decision on a flight purchase? Being a subscription business, we sort of have to do that because that's our credibility. We don't make money from the transaction. We make money on advising people of a potential transaction. And so accuracy and empowering our customers is actually very important for our business. And I don't see a better way to do that than like close partnership with data and data science. I mean, we collect tons and tons of information on their behalf and then try to represent that in a way that is timely and makes sense. But our credibility is also in those numbers. And so people will unsubscribe if they don't see value in the company. And so that's really one of the major things, and why we really require close participation among the teams.
Now, digging more into the architecture, you've already mentioned Iceberg. We already mentioned Trino at the start. You've stated that you're dealing with streaming data flows. I'm wondering if you can just talk to some of the ways that that overall system design fits together and the ways that you're accommodating streaming in that overall architecture.
So we're heavy users of Confluent to collect the streams. We use Starburst Galaxy to tie into Confluent and then transform to Iceberg. There are some intermediary programmatic steps that occur also derived off of Kafka with separate services. And then on the modeling side, we use Databricks. And so Databricks ties to our Iceberg data warehouse to compute models. And then we have services that run in real time that can latch onto Confluent to parse events in real time and run through a model.
When you say model, I'm wondering if you can just unpack that a little bit because it is a very overloaded term.
There's a variety of different applications we use. A lot of it is just predictive analytics. If something is a good deal or not is, we use like Z clustering for that in terms of like, okay, like on what threshold of a deal does this sit? And then, we are getting a little more into ML because we have to, when you start incorporating things like advanced notice and seasonality and velocity of like number of searches on a domain, like the problem space gets progressively more complex if a customer says like, I want to fly specifically on this weekend. Right? You can analyze a whole year's worth of data and determine like what the highs and lows of pricing are for that year. But like to find the right price for the right duration and a right timeline incorporates progressively more complex techniques to do that. So yeah, like that, but that's how we're doing it today. And then there is the BI side of how we model and cluster user behavior and cohort and those sorts of things.
Now, we've established what your current architecture is, some of the different system components. I'm wondering whether that is how the overall system design started, or whether you had maybe a more batch oriented approach to begin with, and maybe what the evolution looked like and some of the challenges of managing that migration process while keeping the business operational.
No, when I started, it's been about a year. It's been an effort of about a year. It was really centered around a Ruby monolith and then a tool that would ingest data but not capture data. And it was kind of like an expert rules system as to how we found flight pricing, but kind of rudimentary and very rules specific and focused. And the rules were kind of tweaked by humans. And so one of the things I wanted to do when I came in is you're not going to actually be able to scale with a system like that. The order of magnitude of where we would need to go and still be human curated is just it's just not possible, honestly. And we were a Snowflake customer at the time, a lot of batch oriented processes in Snowflake. I chose to go to a more open stack just because I saw the volumes of data we would be ingesting as a business and thought the cost magnitude in Snowflake would be eventually prohibitive. And so one of the reasons I like the open Lakehouse architecture is that it lets me commoditize compute and lets me use different vendors for different purposes and actually really tweak and refine how we handle things. Like in-house today, we use Spark for a couple different things. We use Athena. We were using Athena to load into Databricks initially because it was the easiest way to get data into Databricks. Now Databricks though has acquired Tabular and now they have a native Iceberg integration. And so we're talking to them about like maybe potentially using that. So but those options are open to us because we follow an open Lakehouse architecture. So that was really an important thing for me to lay out, just because I wanted the optionality for the business to be able to expand in a bunch of different directions. And I think if you're building a data derived company today, I do think it's a better pattern. I think being able to separate storage and compute with a format that is both fast and has a variety of, I'd say, cool functions in it is probably what the future should be. And so that's sort of where I netted out on that. And so that was the first thing we laid out. But now that we have like unified ways to process data and handle pipelines, it's a lot easier to incorporate new data sources, to incorporate new models. One of the things I'm working on is like data democratization for our business customers and how we actually get out of having analysts have to author every dashboard and data engineers have to do every aggregation under the sun. To try to make data the center of the business is really kind of my major focus. Because if you think about what we provide, we're a recommendation engine for flight pricing, which is all data. It is all computation. It is all data. We'll have a UX. We have brand specifications. We have marketing and efforts and those sorts of things, but those are also derived from data and our user behavior.
In terms of the selection of systems and the structure of the overall architecture, I'm also interested in maybe the whys and wherefores of how you ended up with Iceberg and Trino as the core of that system, particularly given the streaming nature and the fact that you are using that data for a consumer facing use case. And Trino is definitely very scalable and performant, but not typically in the way that you would think about from an application design perspective, where you want to have query responses in the order of milliseconds or maybe low hundreds of milliseconds at the most. And also on the Iceberg side, typically when you think streaming Lakehouse, I know that Hoodie has positioned itself as the answer to that because that was the core of what it was designed for. And I'm wondering kind of what that evaluation and selection process looked like to get to where you are.
Well, choosing format was an important distinction for us because of the volume of the data set. It gets prohibitively challenging to switch formats. And so when we did the initial analysis of popularity of the formats, what we see vendor integrations, because as I sort of mentioned earlier, we are vendor centric, where I see the market going, where I see the most effort businesses are putting into the format, Iceberg kind of stood out for us. I'm familiar with Hoodie and its capabilities, and I'm familiar with Delta and its capabilities. But for me, it was like a VHS Betamax thing where you don't really want to be putting everything in Betamax. And so for me, it was targeting where I thought the business was going. And it turned out I think I'm still correct. I think it turned out to be a correct decision for us. I like Trino for analytic purposes and purposes of aggregation huge data sets. Like that's what we mostly use it for today. For consumer data, I am all for caching pushing or pushing data to different data sources. For instance, we heavily use like a open search for our site for like deal searching and those sorts of things. And so for me, it's like if I have to lift and shift for consumer applications and cache like current stuff outside of our warehouse, we'll do that. I think it's really like right tool for the right job. And so, Trino is an analytics beast, and I think, and it's been great at processing these large data sets. I probably wouldn't use it for right to consumer applications unless I thought it was more cost performant than an Elastic. But the volumes I'm pushing into Elastic are not prohibitive enough, or the indexing is too expensive yet. And so that's where we are today. But I think one of the best parts of an open ecosystem is having multiple engines be able to tie into it and having multiple patterns with which to extract data. And so that's really what we've targeted and focused on. But I do have to abstract what is required to operate a real-time app where people expect fast results versus like being able to seek across large volumes of data for calculation purposes and then eventing purposes. Because if you think about the way a lot of people engage with apps, and this is the way we try to encourage people to engage with apps, is it comes down to push notifications. So like what drives our push is massive volumes of data and massive volumes of processing, and then we decide when to push to our customers, and that is basically based on our historic and data warehouse data. When we do a push though, we want someone to come into the app and have a fast response, and so like the things we have notified them about will be fast and current for them, so they can just pop in, look at the deal, determine if they want it, and take an action. And so you can kind of work both sides of that and try to find the right technology mix to do that sort of thing.
And I'm also wondering if you have done any evaluation of some of the recent OLAP engines. I'm thinking in particular in terms of ClickHouse as one of the popular options, although the fact that it has the co-located storage and compute I can see as being a potential reason against it in your case. But also the Pinot project is another one that comes to mind as far as an option for OLAP and for being able to actually directly serve some of those end users because of the fact that it is optimized for those fast query responses.
I play with both Pinot and ClickHouse. I think we're like I don't want to say a name. We're about like a observability system that I'm 99% sure uses ClickHouse based on the cost economics of it. For me, it's in engineering leadership. Sometimes we pick something and we stick with it until it causes problems later. And so I have a lot of intellectual curiosity in Pinot and ClickHouse and those sorts of things. Like honestly, Postgres and Elastic are doing the consumer job for us today. And until it becomes like cost prohibitive or scale prohibitive, we probably wouldn't take a step back and reevaluate, because it is about cost performance. And until something becomes a problem there, like I want to keep engineering focused on more of like the intellectual property generation than kind of cutting over data stacks. And so if performance became a problem, we would 100% evaluate that, right? It's just not a problem today. And so I think it's just, setting up your KPIs effectively to say, all right, the app has to respond in this amount of time. If it can't, I mean, that's why Elastic was brought in the first place, right? Was that the relational database was way too slow at assembling results for some of these queries, and it was just a lot faster to get the results out of Elasticsearch. I know Elastic has limits. I've used Elastic extensively in my career, and at some point we would look at we will probably end up needing to replace that at scale. But for today, in our kind of like awkward teenage years as a business, it's also cost effective and appropriate. So.
And I imagine, too, that part of the ways that you are transforming and representing the data as it gets to that consumer interaction layer also makes it more conducive to a record-oriented approach where Postgres and Elastic are able to operate across it effectively. You're not going to have a pattern where the user interacts with the application, says, I want to search for a flight from Boston to Berlin, for example, and then you then have to go and scan across thousands or millions of rows. You've already pre-computed the optimal options for that pairing of locations.
Especially with an app form factor, you really have to craft the data you're returning to the app to the form factor, because you don't want to send apps tons of data. They don't have great processors. They could be on limited bandwidth. And so extraneous data tends to slow down your customer experience. And so the hope would be that you are notifying them and targeting something specific and exactly sending them that data. And if they want to do exploration, that's fine. But the good thing is in travel, people expect the experience to be slow. So once people get off the well-worn path of like, here's a notification, here's what we found for you, it's a fast experience there. People have kind of learned that like, if you search for a flight, you're going to sit there for 30 seconds, we've all used Kayak or Expedia and you see the flight results. I mean, you can make it look interesting, but at the end of the day, those systems are all slow. And so I get a little bit of a pass on speed just based on people's normal experience with travel. But, at the end of the day too, though, the problem is you're also getting, in many cases, hundreds of results back from multiple providers that you have to mesh together and then return to the customer. And so that's actually also where we go back and forth between REST and gRPC, right? Like, when do you stream data versus when do you have a RESTful interaction? Because, like, in some cases are definitely streaming cases.
In terms of the orchestration of the overall end-to-end data flow, obviously you have your Kafka stream for the data ingest, you have Trino and Iceberg for manipulation and aggregation, you've got Postgres and Elastic for presentation, but how do you manage the triggers, the workflows, the dependencies, and observability across those different data streams to ensure that you're achieving the latencies that you're targeting and making sure that any errors are identified ahead of time? And this is probably a separate question, but given the fact that these are consumer facing data flows, I'm also interested in what the uptime requirements are and some of the on call requirements that you have around those data flows.
Yeah, right now we are a big Datadog shop, and I find companies our phase typically use Datadog. I would say in general, like companies our size use Datadog just because it is like an all-in-one shop for all forms of observability and lets you stand up things rapidly with minimal effort from engineering. I think as engineering shops get more advanced, like you start leaning more of the Prometheus route or looking at other systems that can do this sort of tracing and analysis, just because Datadog gets expensive for a lot of this stuff. But right now that's what we're mostly targeting. I would say in terms of like uptime and on call, like incident response is a thing, and we try to categorize different forms of incidents. Like if the app or site is down, that's definitely like a P0, all hands on deck. Like, we got to get it back up and running. Depending on what pipelines fall, or we can kind of order those based on order of magnitude. We try to have run books and parties in each of the alerts. So we know something's going on, we can alert on it and then decide what the relevant action is. We have a blue team internally that responds to events. Engineers take a rotation where there's a primary and secondary. Your secondary for the first week, primary for the second week. So it's kind of a handoff and transition of shadowing instance. And that's worked for us. I'll say, like, we target 99.9 because also that's what most of our vendors give us. And so it's really tough for us to stay up past 99.9 if it's the only certainty we're getting from other places. But I would say that, like, we're also not like a hospital. There is some amount of tolerance for downtime because it's not like a critical operating system like I've had to work on in previous aspects. Like, we're talking like 99.9 or those types of systems. But we are a subscription service, and it's frustrating for our customers when we are down, and so we try very hard to hit that 99.9.
As far as the architecture, I imagine that because of the fact that you are using Postgres and Elastic on the serving and presentation layer, you're caching the data there. You have a certain amount of room for errors earlier in the stack because you're not going to bring down the whole site if you fail to get the latest batch of data from one of the data providers. It's just going to be stale for a little bit longer than expected. And I'm wondering if you can talk to maybe some of the ways that you are managing the overall data lifecycle, because obviously there is a certain timeline to the utility of flight data where once the flight date has passed, your customers don't care anymore. It's useful from a analytical perspective to be able to maybe do some projections and analysis of whether a particular price is good or not, but for the consumer, they don't care once that flight has flown. And I'm wondering if you can talk to some of the ways that you manage the life cycling of data in that presentation layer, how far into the future it can even project versus the data size and performance requirements on the consumer layer.
Yeah, and that's where the active and passive shopping comes into the mix, because passive data for me is opportunistic data in that, like, we don't pay it's much cheaper for us to look at other people's searches than to execute our own searches based on the way search query and performance works. So at the end of the day, I save bottom line money by processing huge amounts of data. But at the same time, like, if I don't get for some reason any searches from, like, JFK to Hawaii, because a lot of people want to go to Hawaii, then I have to active search for that data, which means we'll pay for it and do a ton of searches to try to collect pricing information. And so like that's really where the differentiation is. It's like, how are you populating your flight? I mean, I sort of call it like a flight cache, like of data. Like every day we try to get results from passive data to know what existing flight prices are for a huge amount of timeline. That's why the data volumes are so prohibitively large in many cases, is because we are getting a lot of that. But I have to layer on top of that and check the cache if I haven't gotten events, and then actively search for and populate that data. Because if someone is watching a flight, they're paying us to watch it for them. And so we have to find that data if we don't have it in our system. So that's sort of how that side of it works. And so for me, it's if a feed goes down, like one of the large feeds go down, and I miss an hour or two's worth of data, I miss potential deals and I miss cost savings based on the data that I could populate, but I can still find that data because I can still search for that data. And so, but that's, but doing this in a way where we can remain cost competitive, it requires passive data to do it, because it's just, I would pay millions and millions and millions of dollars every month for the number of searches we need to do.
And for the orchestration piece of ensuring that the propagation of data is proceeding, what are you relying on for that overarching control plane?
That's the thing we're still working on. And so right now we will run a job scheduler to search, because we have a number of users who have set up stuff in the system, but it's still a finite number that we can process. And so we can scan that, check the cache. If it doesn't exist, repopulate from active search. At some point, though, we'll probably need a control plane mechanism that will auto populate the cache and do a lot more intelligence. But for now, we're kind of hacking it with just, well, we know what people are looking for. Again, but that number gets prohibitively large, and we have to think of a new system to build as a result of that.
As you continue to build and iterate this system, you mentioned that it's been about a year in the making to where you are now from where you were previously. What are some of the other technologies or other architectural components that you are currently evaluating, planning for, and what are the pieces that you feel are fairly well established and are not at any risk of changing?
Well, I mean, it's funny because it's like you can swap in components, like some of the different componentry for some of these things. Like fundamentally, I do believe in event streaming. Like I believe in like kind of a message bus style or event streaming architecture. There are different technologies in there. We use Confluent today. We could use insert service there tomorrow, right? There's competitors to Confluent and Kafka now. It's like and so for me, it's about what makes sense in the natural evolution. I would say like the one thing that is sort of immutable right now for us is Iceberg, in that we're landing in it and we have no desire to leave it. And I think hopefully the technology ecosystem mirrors that, but it's Galaxy today, and really enjoy using Galaxy as a Trino provider, but I could run Trino, I could run Athena, I could run Dremio on top of Iceberg, and so for me it's like, I'm not looking to switch components out, because well, one, it's sort of a new space and we just stood it up. Like we made some pretty self-conscious decisions initially when we selected this stack. Like, we evaluated SageMaker and Databricks on the ML side, and we went with Databricks. And the odds of Databricks disappointing us for our ML problems in the long term are low. It's a pretty low. I think what we're doing, I think it's a good tool set for that. An area that we're leaning into in terms of future expansion, though, is LLM. Like I think trying to figure out how we do content generation and copy, or explaining our logic or reasoning for why we would recommend a destination to a customer, but not having to have a human being write that to them. Because if we know somebody is watching a lot of travel places, right? Like a lot of like tropical travel places, like they're looking at Aruba and Hawaii, and let's say a couple of the Caribbean islands. Like, why, if we find a deal for the Azores, right? Like we have to tell them why we're saying, well, hey, I know you set up these things, but here's why I recommend the Azores. Here is what you can do there, right? Like that's a perfect use case for LLM. We've written travel publications internally on a lot of these places and could probably summarize that content pretty readily. And so like that's an area of like, let's going over all of our unstructured data that we've written over the past 9 years as to how we could like reflect that to customers and reflect that experience to them, is something we're considering. But that would be, and I think that's, we're talking to some folks about a pilot there in the first half of next year, because I think right now we're kind of done with the overall like data flows that we need in our system. And it's because it's a new system, it's pretty good for now. And so it's like, okay, now how we can leverage this more. Probably 2 years from now, I'll be like, oh crap, like we should probably reevaluate how we do all this stuff. But for now, I feel pretty confident in it.
Yeah, and to your point, Iceberg is definitely on the upswing as far as adoption and integration across the stack. And in particular, I think the Arrow ecosystem is really investing in support for Iceberg. And so that also expands the interoperability and the capabilities, particularly in maybe that more ML oriented ecosystem because of the investment that's happening in the Python and Rust communities to be able to interop with Iceberg.
Yeah, 100%.
And in your work at Going, building this stack, powering the application, what are some of the most interesting or innovative or unexpected ways that you've seen the data or the overall data stack used?
So one of the things I love most about consumer facing businesses is it's all data and insights, right? It's it's you push a feature, you see how people respond to it, you respond effectively and appropriately. And I'd say like learning things about our customers and learning things about behavior and learning things about the changes of technology are always really intriguing to me. Like minor tweaks in an onboarding flow can wildly unlock different scenarios. And so for me, it's like, but you don't know that unless you're collecting the data and getting fine grained about customer behavior in certain instances. And so I love the insights that that generates. I love the complexity of how we come up with an eventing schema and how we track an eventing schema and how we take millions of events and try to aggregate trends out of them to help drive our business and business strategy. We are a very data centric and data focused business these days. And so I'd say that's it's seeing a feature that you thought was going to be minor wildly land and seeing the data come in for that, or it's like seeing something that you thought was going to be awesome, just like 2% of users adopt it, and you're like, oh, that's kind of sad, you know. But those types of things I think are really intriguing for me. You know, I'd say the other thing I love looking into is global flight trend data. Like, where are people looking to go, right? Like, what is a desirable location? Like, you know, you could probably see the impact of Taylor Swift's tour across the US in terms of flight searches. It's things like that where you could do weird kinds of relationships. Because, like, you know, for us, like, we're looking into eventing, right? Like, maybe we should help people fly to see Taylor Swift as a feature, right? And so we can look at data for that and see if it's a global trend and see what it does with flight pricing and see if it's a thing we could offer our customers. Things like that are pretty neat.
Given the fact that the overarching mission of the business is helping people get from here to there at a reduced price, what are the opportunities that you see for incorporating other modes of travel and price analyses on that?
I'd love to. I mean, I think I think you know, European travel trains, huge thing. The and we're starting to look into further partnerships around that. Like, how do we actually help people do next phase trip planning? Like, flights is part of it, but I'd say Going's mission in the long term is to try to be a generalized travel advisor. Like, we started out with flights, but hopefully we could help with accommodations or recommendations of things to do, or or offer alternative modes of transportation, let people trip plan, let people share their trips, see what other people are doing around trip planning. I think those types of things are kind of interesting for us to lean into. But it's like 25 engineers are still still locked on flights. So, but no, that's the growth. That's the growth path we see for us. With a largely U.S. focused customer base, though, flights is still the biggest because the rail system in the U.S. is pretty, unless you're traveling on the East Coast, pretty spotty. And then so, and then we've leaned to get people into Europe thus far, but not like what you do once you're there yet. So.
And in your experience of coming to Going, helping them rebuild their data stack, reimagine the way that their overall system architecture operates, what are some of the most interesting or unexpected or challenging lessons that you learned in the process?
Data platform cutovers are always a hustle. Like, no matter how well you plan or how well you do everything, there's always this awkward phase of doing the last mile and cutting over from one system to another, and then all the errors that arise from that in terms of like dashboards and business critical stuff that kind of collapses. We as an exercise with the migration from Snowflake to Iceberg. We targeted our schemas too, and we did a schema overhaul in parallel because like we thought some of our schemas were inefficient for where we saw the business going. And so like doing all that simultaneously was a big project, and it always turns into a mess at the end. I would love to figure out a better way to do that. I haven't yet. And so that's been interesting. And then there's the customer education because we did move from preset to quick site. We were using a superset under the covers for a while, but decided to keep everything in the AWS stack because I think Amazon Q is interesting. I think the NLP stuff they're doing with Bedrock is interesting. My eventual goal is to get non-technical users to be able to actually describe and define dashboards and have good enough schema that it could probably handle that kind of specification. And that's a work in progress. It's still not there. You still have to kind of know how to tune the bot to a certain extent. But
We already talked a little bit about some of the plans that you have for the forward-looking goals of the going data architecture, but as somebody who is operating in the data space, what are some of the overarching trends or technologies or just areas of personal interest that you're focused on and keeping an eye towards as you continue to lead and grow and scale your data operations?
having built stuff like this from scratch and then looking at where we are today with just the sheer amount of options in market for virtually every kind of data solution that is like wildly more scalable than what we were using, let's say like 6 or 8 years ago, has been really awesome to see. And so for me, like building something this big and managing this volume of data without the tools we have today would be impossible for a team my size to actually manage and handle and operate. And so for me, like that's been a huge differentiator in market, just the sheer amounts of concurrent data you can stream in and it not be a big deal, the way you can land and process that data at the multi-petabyte scale and that not be a big deal. Like those things were a big deal at other phases in my career. And so like that's been awesome to see from that perspective. It's been kind of and even having to build service frameworks to serve different algorithms up and do my own custom A/B, like all that, you can get a lot of that out of the box. And those are pretty large engineering challenges. Like those are like employing a team full time to work on those sorts of things. And so that's been super cool, that you can actually do a lot of stuff with not a huge amount of humans, and you can do ambitious stuff with not a huge amount of humans required. Has been a pretty big unlock for engineering.
Are there any other aspects of the work that you're doing at Going, the data architecture and platform architecture that you have established, or the overall applications of the Trino and Iceberg combination that we didn't discuss yet that you'd like to cover before we close out the show?
One of the things I like about Trino and Galaxy in general is that they are trying to build a cohesive iceberg management solution. I think with Tabular getting snapped up by Databricks, I think, but and it's still sort of be like promoting Delta under the covers. I think like for me, being able to work with an open Lakehouse architecture and actually like work with Trino as a technology, because Trino is a great technology, but it used to be kind of a pain to manage all those clusters. And I'd say like Galaxy has provided a lot of transparency on that, and they provide some data management capabilities on top of it. I think data management is an area that kind of lacks in a lot of tool sets that I've worked with in the past.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh man, data quality is still an issue. Quality checking, it's still an unsolved problem. I think unless a feed completely breaks, like it's tough to detect bugs in data feeds accurately. I think application of AI potentially in that space is very interesting. And I'd say like data education and lineage is still really hard, especially as companies become more business derived and driven. Like it's still tough to kind of articulate, you should rely on this data set because it is concrete and transactional. Like it integrates with our payment processor, and that is physical money in our bank account, versus this is a tool that is hooked up to our website and is about 20% inaccurate. And like you should use it for directional data, but not hard business decisions. But like education on that and marking that, and when people like it's tough to propagate that context to customers is what I would say. And so for me, like that's still an area that we have to invest in and solve as a business. That and like data leakage, like people are still leaking PII and like the governance side. So it's the non-technical probably portion and the policy and quality portions of data management that I still think are challenges.
Absolutely. Well, thank you very much for taking the time today to join me and share your work of building this data architecture and the ways that you are using Iceberg for streaming ingest. It's definitely a very interesting problem space, interesting solution that you've developed. So thank you again for taking the time, and I hope you enjoy the rest of your day.
Thank you. Thanks for having me. This was awesome.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.